All right, greetings there, chemistry students. What we're going to be doing today for our tutorial is the CP Chemistry Concentration Review Sheet. I'll be focusing on number 4, 5, and 6 from that particular review, okay? And what you need to have in front of you, of course, is this sheet, also your periodic table, and you'll also need your calculator, etc., to make sure you got everything set up, ready to go, okay? So the thing with these concentration problems, okay, and again, taking you all the way back to that first couple of days of class, very beginning of the year, where I talk about units are paramount. You have to pay attention to what units you're using to represent the type of concentration that I'm asking you to represent, which could be molarity, molality, mole fraction, or percent mass, all right? And it's units that determine what type of concentration it is. So yes, you need to show your units as you go through the problem, okay? And yes, the units need to be in your answer, and yes, that will affect your score, okay? It's not just about knowing which numbers to put on your calculator, when to divide, when to multiply. It's about showing how you got from one unit to another. That is the skill that's being assessed here, all right? So keep that in mind. That's what I'm going to demonstrate on the board. That's what I expect to see on your paper when you take the test, okay? So anyways, number 4, I wrote abbreviated forms of the questions up on the board just as our guide, and I can refer to that. But it says, what is the molality of a solution that is made by dissolving 32.6 grams of sodium hydroxide into 1,200 grams of water? All right, so molality, right, we need to know, right? This is not something that will probably be given to you on the test. You need to know that when it says molality, I want to know moles over kilograms. And it's moles of solute over kilograms solvent. Okay? That is what we're trying to accomplish here. Okay? So moles of solute divided by the kilograms of solvent is what we're looking for in this particular one. And I have to know that's what molality means. Okay? So what I do then is take what I'm given in my problem. I have 32.6 grams dissolved in 1,200 grams of water. So first of all, we have to know what solute means and what solvent means. Solute is what gets dissolved. Solvent is what does the dissolving, right? And for most cases, the solvent for us is going to be water, all right? So whenever you see water, you should automatically know that's going to be our solvent, all right? That's not 100% always true, but for what we're doing, it's going to be true. All right, so I need to know how many kilograms of water I have. I need to know how many moles of solute I have. In this case, how many moles of sodium hydroxide do I have? Okay, so that tells me how to solve my problem. I need to know the kilograms of solvent on the bottom. I need to know moles of solute on top. What do I know? I know the grams of solute, right, and the grams of water. Now, I told you guys early on, quick mental conversions would be milliliters to liters, grams to kilograms. So we should know if I have 1,200 grams of water, right, that is 1.2 kilograms, right? Because just move the decimal 3 places to the left. So grams to kilograms, 3 places to the left. Milliliters to liters, 3 places to the left. Make those mental conversions, right? If it's already in kilograms, of course, we wouldn't have to make that conversion. All right, so that gives me kilograms on the bottom like I want it, right? I have 1.2 kilograms of water, which is equal to 1,200 grams of water. Now, what I'm going to have to do then is take the amount of solute that I'm given, which would be 32.6 grams, all right, and I need to then run a conversion, okay, to figure out how many moles that is. So I have grams over kilograms. I want moles over kilograms, all right? So I'm just going to do my conversion from grams to moles like we've been taught, right? And yes, you really ought to know how to do this by now, okay? If you don't know how to do this by now, you're going to be in a world of trouble. Learn how to go from grams to moles and moles to grams. For crying out loud, it's a one-step division or multiplication problem. Learn that. I knew you guys think I was mad. but do learn that. All right, anyways, we have 32.6 grams of sodium hydroxide. How many moles is that? Okay, we need to know the molar mass of sodium hydroxide. So the molar mass of NaOH, I take one sodium plus one oxygen plus hydrogen, I get 40.00. All right, so that would be 40.00 grams in 1 mole. All right, now if I do my unit cancellation, I'm showing moles of solute, so moles of sodium hydroxide over kilograms of solvent. So I'm just going to go 32.6 divided by 1.2 divided by 40, and I should get 0.68 little m, right? So molality, remember, is represented by a little m. You could also do moles over kilograms if you want. That is perfectly acceptable. And we also need to include what it is that we're talking about. All right? So, full points on your test, okay, will show what units you started with, how you got to the units you wanted. Your answer will show the unit and what material it is and the correct number to get all of those points. Those are the things that you have to show me. Okay? So that is number 4. We wanted moles of solute over kilogram of solvent. Yes, you have to know the difference between solute and solvent. You should be able to pick that out of the question without a problem. It's a vocab question. Okay? Then you figure out what units you're given to start, and you know how to make those conversions. Yes, you should know how to go from grams to moles by now, for crying out loud. Know how to do that. Okay, number 5. It states, calculate the mass of H2SO4 needed to make 250 milliliters of a 3 molar solution. All right, so I want to know how much H2SO4 I would need to dissolve into water to make a 3 molar solution, okay, at a volume of 250 milliliters. Okay, so the way to attack a problem like this, okay, is what is the concentration I want? So again, this is like the last problem with molality, except that rather than starting with a certain number of grams, okay, I'm going to start with the concentration and work backwards to how many grams that is. Okay? So in this case, I want my answer to be in grams. Right? That's what I want in my answer. All right? Now, what am I given as a starting point? I'm given a concentration in molarity. So the capital M, again, you need to know this, the capital M molarity is moles per liter, right? Moles of solute per liter of solvent. So in this particular case, right, I know my molarity to be 3.00 molar, right? So that's 3.00 moles of H2SO4 per 1 liter of water. Okay, now, because this is already given as a molarity 3.00, we can probably go ahead and do this too, right? Because we know that many sig figs. That way we don't get thrown off thinking there's just one sig fig there. But anyways, all right. So, what do I want my answer in? Grams. Okay. Now, so if I have moles per liter, how do I cancel out the liters? How do I go moles to grams? And so on. So let's just think about what we're trying to do here. All right. How much of this do I actually want? I don't want a whole liter, do I? I want 250 milliliters of it. All right. So one thing I'm going to do is I'm going to convert moles to grams, and then I'm also going to then say, oh, I don't want a whole liter. I want about a quarter of a liter, which is 0.250 liters. Okay. So again, there's 2 conversions to make in this problem. First of all, I want to know my answer in grams. We know how to go moles to grams. We should know that. Okay? And then likewise, I need to get rid of my liter unit. Okay? So, I have 3 molar solution, or I want to make a 3 molar solution. Alright? So that's 3 moles per liter. I don't want a whole liter. I just want this much, which would be 0.250 liters, right? So again, that quick mental conversion, all right? So I'm gonna go ahead and say 0.2500 liters right there, right? Because I want to cancel that unit out. So that tells me if it's on bottom here, it needs to go on top there, right? That's also going to account for the fact that I don't want a whole liter, all right? So boom, boom. So now it tells me, if I was just to multiply right now, that would tell me how many moles of H2SO4 I need, right? Just because it's not going to be an entire 3 moles because I don't have an entire liter. Right? If I had an entire liter, it would be 3 moles exactly. I only have 0.250 liters, that's all I want to make, right? So this would tell me how many moles I want. I want my answer in grams. Can we convert moles to grams? Of course we can. Moles to grams, right? Now, in 1 mole, how many grams of H2SO4 are there? That is 98.03. Okay? So there are 98.03 grams of H2SO4 in 1 mole. Right? So now if I go back and I pay attention to my units, I'm left with grams, which is what I want in my answer. So again, what was I trying to do here? I wanted to know how many grams of sulfuric acid, H2SO4, I wanted to dissolve into water to make it an acid in the first place. Okay? But I didn't want an entire liter of 3 molar, I wanted just 0.250 liters, right? So I take the concentration I want, 3 moles per liter, multiply it by the amount I actually want, all right, which would be just 0.250 liters, right? That gives me moles left over. I convert moles to grams in the way we've been taught and been working on forever now, right? And we should get an answer with 3 sig bits, all right? And so that would be 73.5 grams H2SO4. Okay? All right, and there's my 3 sig figs indicator right there. So to make a 250 milliliters of a 3 molar solution, I need to dissolve 73.5 grams into 250 milliliters of water. All right, so if I was to describe to you how to make 250 milliliters of a 3 molar solution, I'd say dissolve 73.5 grams of sulfuric acid into 250 milliliters of water. There we go. Boom. All right, last but not least, is a mole fraction problem. Okay, and again, this is another way to represent concentration. Okay, it's just as a fraction. Now, a fraction of parts should always add up to 1. All right, and it's an important concept that we'll get when we get to part B that we're going to have to remember. Okay, so if I have 123 grams of ammonium nitrate dissolved into 525 grams of water, I want to know the mole fraction for ammonium nitrate and then the corresponding mole fraction for water. All right, so for mole fraction, we need to convert all of our quantities into moles first, right? So off to the side somewhere, just convert grams of this to moles, grams of this to moles. Then you've got your mole problem, okay? So that's just remember that. Remember that. Mole fraction, everything needs to be in moles. All right, so I have ammonium nitrate and I have water. Those are both given in grams. I need to convert grams of this to moles and grams of water to moles, okay? So off to the side, we can do a quick calculation, right? So before we even start A and B, convert everything to moles. Convert everything to moles for mole fraction. Convert everything to moles for mole fraction. Convert everything to moles for mole fraction. Okay. So I have 123 grams of ammonium nitrate. All right. 1, 2, 3 grams NH4NO3. Right? I want to go grams to moles, right? We should know how to do that. I take nitrogen plus 4 hydrogens plus another nitrogen plus 3 oxygens, and I should get 80.06 grams in 1 mole, and that would give me 1.53 moles of ammonium nitrate. Okay, then I'm going to take my 525 grams of water, Okay, so I have 525 grams of water, right? And there are 18.02 grams in a mole, right? So when I divide that, I should get 29.1 moles of water. Okay? So these are the numbers I can use for my mole fraction equation, right? So how do I set up a mole fraction equation? Now this is an equation I will give you, okay? So it is simply moles of part over mole total. All right, and you'll get a decimal. That's how easy this is, okay? How many moles do I have total? So that plus that goes on the bottom, okay? Which part do I want? Look at the question. I want to know the mole fraction of ammonium nitrate. So my mole part would be the number of moles of ammonium nitrate. So for 6A, how many moles of ammonium nitrate do I have? 1.53 over total 1.53 plus 29.1. All right, and I add first, then I divide. That's why I put the parentheses there, right? So this is my total moles, those two combined. Which part was I looking for in letter A? Ammonium nitrate, so that's the number that goes on top. And when I do that, I should get 0.0500. All right, that's an ugly looking 5. All right, now mole fraction is a unitless number, right? It's a fraction, okay? Now for part B, we could do this one of two ways. We can do this either way, all right? I can then take the same equation right here, and I can take 29.1 and put it on top, because in this case, I'm looking for the mole fraction that is water, so the moles part would be for water, so it'd be 29.1 over the total. Or, because with fractions, all the parts should add up to 1, right? I can just go 1 minus 0.0500, right? And that would give me 0.9500. Easy as that, okay? So for mole fraction, you convert everything to moles, all right? Once you know how many moles you have, you just plug it into this equation, moles of part divided by the moles total, and there's your answer. All right, hopefully that's enough to get you guys going. I'm not gonna work through a mass percent problem with you because that's easy. Grams over total grams times 100. You guys know how to do percents, okay? Crying out loud. Good luck. Gotta be ready for that test Tuesday.